Good morning everyone. So today we'll see about the lymphocyte activation. So what is lymphocyte activation is that the lymphocyte activates basically by two mechanisms, which is the T cell activation and co-stimulation. T cell activation and B cell activation. They are the two types of lymphocyte activation. Under T cell activation, we have the mechanisms. The first thing is initial recognition. That is, it actually recognizes MHC class 1, recognition of MHC class 1 by the CD8 cytotoxic and class 2 by the CD4 T helper cell, and there will be peptide presentation. And core receptor involvement, as two receptors, CD4 receptors and CD8 receptors are both involved. So it is actually core receptor involvement in T cell activation, initial recognition. And next comes the co-stimulation, signal 2. So signal 1 is TSR MHC interaction, then co-stimulation, where the key interaction is CD28 B7 interacts and CD40L and ICOS interacts with ICOSL. So the consequence of this is cell survival signals, metabolic changes happens, and cytokine production. So signaling cascades will be the next step. So we have proximal signaling and downstream pathways. So in the proximal signaling, we have the TCR CD3 complex activation, ZAP70 recruitment, LAT phosphorylation, and SLP76 activation. And the downstream pathways include calcium signaling, MAPK pathway, NFKB activation, and mTOR signaling. In the metabolic reprogramming, there will be increased glucose uptake, enhanced glycolysis, mitochondrial activity, and lipid metabolism changes. So these all happens under T cell activation. In B cell activation, we have the T independent activation and T dependent activation. So T independent activation, it is type 1, toll-like receptor ligands are present, innate immune signals will be activated. In type 2, there is repetitive antigen happens, cross-linking of BCRs. And in T dependent activation, the initial step is antigen recognition by the BCR, antigen internalization, processing and presentation, and next is the T cell L. That is CD40 L and CD40 interaction, cytokine signaling, and co-stimulatory molecules. And we have the germinal center reaction formation, that is B cell proliferation, somatic hypermutation, affinity maturation. They all happens in the germinal center reaction. Selection also happens in which T follicular helper cells are selected, FDC network, and survival signals. Next is the regulation of the immune response. So auto activation of the T cell, B cell, and all. We should know how it actually regulates. So central tolerance, there is something called as central tolerance, where T cell development, that is thymus is involved, positive selection should be there, MHC restriction, survival signals should be there, and in negative selection, self antigen recognition should be done, and clonal deletion of that particular thing happens, and regulatory T cell development. Next is the B cell development, which is the bone marrow. We have the checkpoint controls, pre-BCR expression, autoreactivity testing, receptor editing, selection mechanism involves clonal deletion, energy, and receptor revision. Peripheral tolerance, there is something known as, first we saw about central tolerance, now peripheral tolerance. In peripheral tolerance, we have cellular mechanisms, energy, that is functional unresponsiveness. So lack of co-stimulation, inhibitory receptor signaling. Then we have deletion, activation induced cell death, fast FAL pathway, BIM dependent apoptosis, and we also have regulatory T cells, that is natural, that is thymic, induced is peripheral, and FOXP3 expression. B cell regulatory cells help in interleukin 10 production and TGF beta, tumor growth factor beta secretion. So the molecular mechanisms to involve this, inhibitory receptors and suppressive cytokines. Inhibitory receptors, we all know the inhibitory checkpoint, CTLA4, PD1, and LAG3, TIM3. And suppressive cytokines includes interleukin 10, tumor growth factor beta, and interleukin 35. Then we have active regulation, cytokine networks. There is release of pro-inflammatory cytokines, interleukin 1 and 6, tumor necrosis factor, and interferon gamma. And we also have anti-inflammatory interleukins, interleukin 10, tumor growth factor beta, and interleukin 4. Cell population balance should be there. T helper cell subsets. Th1 and Th2 balance should be there. Th17 and T regulatory ratio should be normal. And we also have B cell regulation, that is a memory versus plasma cells. Antibody class switching is there, and affinity maturation should also take place for active regulation. Then homeostatic control, maintenance mechanism, that is cytokine dependent survival, homeostatic proliferation, memory B cell persistence. Then population dynamic, name or memory balance, effector or regulatory ratio, and tissue distribution. Next we have dysregulation and disease. When there is dysregulation in this immune response, we undergo autoimmune disorders, break in self-tolerance, and genetic factors are also obviously involved along with the environmental factors. It can also be associated with immune deficiency, that is defective activation, impaired regulation, compromised function, and allergic responses, that is Th2 bias, IgE production, and inflammatory mediators. What are the therapeutic applications? Is immunomodulation, checkpoint inhibitors, and co-stimulation blockers, cytokine therapies. And cell-based therapies, we also have CAR T cell therapy, regulated T cell therapy, and tolerogenic dendritic cells. Yeah. Thank you.